Let's work through this worksheet on volume of solids with known cross sections. Now, so this is number 1. Find the volume of a solid with a circular base of diameter 10 whose cross section is perpendicular to the given diameter are equilateral triangles. So a couple of things here. Volume. So right now we only have one way to do volume, and that is to do a cross section. And every time I hear those words, volume and cross section, I think all I gotta do is integrate the area formula. That's it. I gotta integrate the area formula. Now in this case, we have equilateral triangles. So you have to remember what your area formula for that is. In equilateral triangles, the formula is area is square root of 3 over 4s squared. So that's what we're going to integrate. We're going to integrate this guy from our limits, and we got to figure out what s is. That's the other important part. But the first step is know that since we're finding the volume of a cross section, all we have to do is integrate the area formula. So in this case, it's equilateral triangle, so we're using this one. And now the next step is find our limit and find s. So now let's kind of reread this problem. Find the volume of a solid whose circular base of diameter 10. So we're talking about a circle with diameter 10. Notice how they don't give us any other information. So we're going to have to assume that it's starting from the origin. Because it actually doesn't really matter where it is. We'll put at the origin so it's easier to count. It could be over here, over there. It's not going to change the thing. It's going to have the exact same volume. So we're just going to start at the origin. So diameter 10, that means we go 5 this way and 5 that way. And we'll get like a circle like this. Not my best circle, but whatever, we'll live with it. Something like that. So I already know, so right, this side diameter 10, negative 5. And this would go 5 to negative 5 also, by the way. I already know a couple things. Alright, so my integral formula is going to be from negative 5 to 5. It's going to be the area of an equilateral triangle, so we're going to use this formula right there. Square root of 3 over 4 s squared dx. Now I got to find out what s is. Now remember what s is? It's the length of your slice. So it's like, what the length is. So your s is always this guy. And how do we find s? Well, it's the top equation minus the bottom equation. Just kind of like when we did area, top minus bottom. So now it's the tricky part. They didn't give me any equation here. So you gotta remember we're in AP calculus. So the equation for a circle is this guy, x squared plus y squared equals r squared, especially when it's centered at the origin. Now I know the diameter is 10, so my radius this formula is going to be, my radius has to be 5, so x squared plus y squared equals 5 squared. Now we got to put in a formula that we can actually use, so I need to solve for y here. So y squared equals 5 squared minus x squared, then square root it, and I get y equals positive square root of 25 minus x squared, and also plus and minus negative square root of 25 minus x squared. Alright, so again, they didn't give me a formula, but I have to know that if it's a circle, I should know the formula of a circle. X squared plus y squared equals r squared. The diameter is 10, which makes the radius 5, so plug that in, I get this. Solve for y, because we're going to go up and down, and I get these two formulas. The top of which is the positive version, y equals square root of 25 minus x squared, and the bottom of which will be the negative version. And that leaves us asking, what is s? Remember, s is the slice, so it's the top minus the bottom. Top is this guy minus this guy. So my s is going to be square root of 25 minus x squared minus the bottom, which is negative square root of 25 minus x squared. Two negatives make a positive, and they're the exact same thing, so I just get 2 times the square root of 25 minus x squared. That is my s. And that's what I'm plugging into the formula here, right? So again, to go over these things, if I know it's volume of a cross section, all I'm doing is integrating the area formula. So I just got to find out what the area formula is. In this case, it's equilateral triangles, so I use this formula. Next, you got to find out what the s is. What's the s? It's always it's like the area. It's like, what's that slice? What's the height of this thing? So it's top equation minus bottom equation. So top minus bottom gets me this guy. Plug that in for s, and then we're done. All we have to do now is sub that into our calculator. So I get negative 5 to 5, rad 3 over 4, and then I plug all this in, 2 25 minus x squared. And then all of that's going to be, so remember, that is my s. but the s is squared, so it's going to be squared out here, and then dx. Now, like I always like to say, don't be a hero. Just plug. I can't do that by hand. I could. It would be ugly. Plug into your sub this into your calculator. Plug it in. If you plug into your calculator, you're going to get 288.675. This will show you just real quick. I was debating whether to do it or not. I'll do it real quick. But I'll do it this one time. I think the rest I won't. So we go math 9, right? Math integration. We're going to go -5. Keep in mind that when it's a -5 like that, you want to use a negative down here, not the subtraction. Subtraction is in between an equation. The beginning of the equation is always a negative. Put the 5. Inside here, I'll probably rad through 4. I could do alpha y equals just to be sure. So I'll get rad 3 over 4. And then parentheses 2 square roots of 25 minus x squared. Get out of that, close the parentheses, and then that whole thing squared because that's my s. Then we got to put it to the x, right? X, hit enter, and 288.675. Remember an AP, so you could either write all that out, you could truncate it if you want, 3 decimal places, or you could round it. Just make sure you put 3 decimal places at the very least. So that's the first one. Next one. The base of a solid is a region bounded by the graph of y equals 1 minus x squared, that's this guy, and the x-axis. For this solid, each cross-section perpendicular to the x-axis is a rectangle with the height 3 times the base. What is the volume of the solid? So like I always say, if it says cross-section and we're doing volume, all we know, the formula is going to be, it's this integrate the area formula. That is it, right? That's how you find the volume of the cross-section. You integrate the area formula. What's area in this case? It's a rectangle. So you remember what the area of a rectangle is. Now that's one we actually know. Like from area equals length times width or base times height, whatever you want to say. Either one's fine. The thing about rectangle, they have to tell you something a little bit more. So since there's 2 variables here, unlike last time, right, where there's only the s, in a rectangle there's 2 variables. So they always have to tell you what the other one of the variables is. In this case, they say the rectangle with the height 3 times the base. So I know the height equals 3 times the base. So let's get my formula again. So integrate the area, which is base times height, dx. But I know the height is 3 times the base, so let's plug that in. So we're going to integrate b times 3b, which is going to get me integral of 3b squared. Okay, now all I got to do is find what b is. We'll talk about that, and I got to find my limits. And then I just plug into my calculator. So let's find the limits first. So I'm trying to figure out where 1 minus x squared, this guy, crosses the x-axis. So the way we do that, well, the x-axis is also known as y equals 0. And I have y equals 1 minus x squared. So let's just plug 0 in to the y. Right, basically, we're just find the x-intercepts. Add x squared to both sides. Square root it. I get x equals plus and minus 1. I guess I just realized I could just also look at the graph. -1, +1. But whatever. I like doing math. So there's my limits. Okay, now how about b? B is it's the same thing as s, so just whatever you want to use. It's the slice. It's how big is this guy? And all that ever is, it's the top equation minus the bottom equation. So in this case, right, top minus bottom, my top equation is the 1 minus x squared, and my bottom equation is just 0. So b is just going to be 1 minus x squared. So let's plug it in. I'm going to integrate -1 to 1 of 3 times 1 minus x squared, right? That is my b. Then don't forget the formula has it squared, so I'm going to square it again, dx. Plug it into your calculator to get the answer. I did so off camera, so you can see it like this. And plug it in, and you get 3.2, which is the right answer. That's what these are, right, by the way. Those are the answers, so you could check your work. Or we could check our work together. Next one. The base of a solid is the region in the first quadrant bounded by the x-axis, the y-axis, and the line x plus 2y equals 8, as shown in the figure. So that's this little region right there. If the cross-section of the solid perpendicular to the x-axis are semicircles, what's the volume of the solid? So again, like I always say, cross-section volume. So all we're doing is we're integrating the area formula. That is it. for a semicircle, the formula is, right, we know the area equals 1/2 pi r squared. So area of every circle is pi r squared, semicircle is 1/2. Now there's one thing here though, that's trickier than most. Circles are always a little funky. Semicircles is a little bit funkier. So if we draw a little semicircle here, it's kind of like that. I just give you an idea, right? What's our r? It's not the whole line. Our r is actually halfway. I was trying to have something to show that green does not show well. I should have done orange. Orange is so much better. So let's erase that. Okay. Right. That is my r. Right. R is only half of the whole line. So for a semicircle specifically, r equals 1/2 of s. Right. If we consider s like the line, the whole line right here. Like our slice. This is my s. Those guys are my s's. But the radius that we need for a formula is actually only half of that. So it's all about the picture. When I do semicircles or circles, or quarter circles we'll do later, it's all about drawing the picture. So semicircle, oh, my radius is only half of the whole picture. So you got for that one, you got to make sure that your radius is half of s. Once you get s, you divide it by 2. But other than that, it's the exact same thing, right? It's s of my area formula. So what we have right now is we're going to integrate my area formula, which is 1/2 pi r squared dx. I gotta find the limits. Well, let's look at it. 0 to 8. I'm not gonna make the same mistake I made last time. Do all the work for no reason. Right, we're going from 0 to 8. And I'm going up and down, perpendicular to the x-axis. That's what it says, right? Perpendicular to the x-axis. So I'm drawing it like that. We'll do perpendicular to the y-axis in I think the next page. And then next, all I gotta do is find my r. Well, look at the equation they gave us. X plus 2y equals 8. That's not the proper form. Since I'm perpendicular to the x-axis, I can get y by itself. But that's easy enough. We all take an algebra 1. So we're going to get y by itself, subtract x. So 2y equals negative x plus 8. Divide everything by 2. Y equals negative x over 2 plus 4. So that's the equation of a line, and that would also be my s. Because, right, s is just top minus bottom, so it would be negative x over 2 plus 4 over 0, the x-axis. So my s is just going to be that line. Right, because the bottom is 0. So that's my equation. Plug it in. 0 to the 8 of 1/2 pi r squared. Now left r empty for now. Because remember, r is not the same thing as s in this case. For semicircles, it's not the same. Right, s is the whole line. R is half of that. So my r is actually only going to be 1/2 negative x over 2 plus 4. So I'll plug that in like that. 1/2 negative x over 2 plus 4. Sorry, it's so ugly. And another parenthesis dx. That's what I had to plug into my calculator. I'll do that one because that's ugly. So let's do that one together also. So math 9. Right, I'm going from 0 to 8. I need 1/2. I need pi. And parentheses, I'm going to do 1/2 times negative x divided by 2 plus 4. Now watch these parentheses here. So I gotta close that parenthesis, which closes just that times the 1/2. Like that closes that one. I also want to close the 1/2 one, right? Like I want all this to be squared. So I'm gonna close it again, and then hit squared. And then I should be able to go over here and press X, and I should get the correct answer: 16.755, 16.755. So it works. Right, so I hope you notice, it's really just, if you know that area formula, it's actually not that bad. Volume of a cross section, you just integrate the area formula. You just gotta know all the area formulas, and then you gotta know how to find S. Semicircle is probably the worst one, because it's like a little different than everything else. The region bounded by the graph of y equals 2x minus x squared, and the x-axis is the base of a solid. For the solid, each cross section perpendicular to the x-axis is the equilateral triangle. What is the volume of the solid? Okay. So again, cross section, equilateral triangle. I think I meant to say cross section volume. So I'm just going to integrate the area formula. It's an equilateral triangle. We did this one earlier. So I'm going to integrate this formula like that. So all we got to do is find the s. So we got to like draw this thing. So the region bounded by the graph of that and the x-axis is the base of a solid. So y equals 2x minus x squared. I'm going to try to find the x-intercepts. So I'm just going to set 2x minus x squared equal to 0. Because all I really care about is the x-intercepts. And then let's see, factor out an x. 2x minus x equals 0. Split it. 0 and 2 minus x equals 0. So 0 and 2. That was not the cleanest I've ever done it, but there you go. So those are x-intercepts, 0 and 2. So going from 0 to 2. It's a negative x squared, so it's probably opening upside down. So it's something like this. Remember, it's just a sketch. It doesn't have to be perfect. The x-intercepts is what the key is, and then we're just going to use integration to find the rest. So we're going from there to there. And that's a pretty good drawing. So now, and you find out what s is. Now remember, what s is, it's a weird way of saying it, is this slice right here. Right? And we're drawing an equilateral triangle, so it kind of looks like that. On our s. All that is top minus bottom. Top is the equation, is this equation. That's the top of my graph. 2x minus x squared. The bottom of my graph is the y equals 0 line. So my s is just going to be 2x minus x squared. So we can plug that into our equation now. We're going to integrate from 0 to 2. Rad 3 over 4 times 2x minus x squared. Squared, because remember we're plugging it into the s squared formula, so for s is all this squared dx. Plug into the calculator and you would get 0.462. Now you can try it by yourselves. Next one. The region in quadrant 1 bounded by the graph of f of x 1 minus e to the negative x, and g of x cubed is the base of a solid. Find the volume of a solid so we have two different options here. A, for the solid, each cross section perpendicular to the x-axis is an isosceles right triangle with one leg across the base of the solid. Okay, so a couple things going on here. So this is my section. So it looks like we're starting at 0, and it looks like it end at 1, but it's actually not. We got to make sure of that. So we got to find the intersection. And for that, we need to use our calculator. Right, g of x is x cubed. F of x is 1 minus e to the negative x. So let me bring up the calculator. It's right there. Let's go to y equals, and we're going to type in, it doesn't matter which one's first. I'm going to keep f as the top one, 1 minus e. Now notice how it's negative x, so for that I'm going to put negative x. Minus is in between. Let's think by itself, you put a negative x. Or put a negative. And then this one's going to be x cubed. So x, and then caret third power. I'm going to graph it. I'm going to fix my window though. It looks like I'm going from 0 to 2 to 0 to 2. So 0, 2. And then 0, 2. Hit graph. There we go. That's my 1 minus ex. And there's the x cubed. So it looks like 1 minus ex is the top one. So let's find the intersection. Second, calculate. Intersection. First curve, second curve. I get 0.822514. Remember, we're going to store this value. So when we store it, and once we got our answer, put quit. Hit enter. Then we just press store. Put it anywhere you want. I'll put it in A. So now A is my answer there. So over here, we're going to write A equals point, I already forgot what it was, 825115. Something like that. It's probably a little off. And then let's up the integral right now. So since we are doing volume of cross section, let's write cross section volume. We're just going to integrate the area formula. So I'm going to have integral from 0 to my A. Now for area, it's the area of an isosceles right triangle with one leg across the base. So let's talk about what that is. So here's my slice. So it's an isosceles triangle. A right isosceles triangle is going to be kind of like that. That's not a very good isosceles triangle. It's kind of like that. And then it says the legs and the leg is across the base. That means the leg is right here. So you gotta think, how do we find the area of that triangle there? Well, It's an area of a normal triangle. 1/2 base times height. My base is the leg and my side's the leg. Like these are both the same. So the area here is going to be 1/2 base times height, or 1/2 the ugly h s squared. These are both the same. In general, that's the most common area of an isosceles triangle. We will do a harder one in a second, but the most common area of an isosceles triangle is 1/2 side squared, because these are both the same. So that's going to be my formula here. Now all I gotta do is find what the s is. Remember, s is always the same. It's this s right here is the top equation minus the bottom equation. So my s is gonna be 1 minus e to the negative x minus x cubed. So let's sub that in. 1 minus e to the negative x minus x cubed, and then that part is squared. Right, because again, we're plugging in for s happens to be squared. Plug that in, all that into the calculator, and you will get 0.016. And actually, let's just do it. We have no time limit here. We can go on forever, as long as we want. So I'm going to go math 9, go 0 to a. This is why I want to do it. So how do I put a up there? You just press alpha a. We stored it, so it should be good. Then here I'm going to do 1/2, parentheses, 1 minus e to the negative x minus, so subtraction, x squared, x cubed, sorry. Then close it, very important, we have to close the parentheses because you got to square it still. So squared. And then all over here, I'm going to press x. Hit enter. You should get 0.0, right? If you round it, 0.016. Man, that's great. Okay, the next one. The next one's more annoying. For this solid, each cross-section perpendicular to the x-axis is an isosceles right triangle with the hypotenuse across the base. So let me erase this so I get a better picture. So it's the exact same problem. We're still going to integrate from 0 to a, but the area is a little different because it's the hypotenuse across the base. What does that mean? Well, if I draw my little slice like this, that's not the leg, that's not the equal part. That's the hypotenuse, so these two guys are equal. And that's the hypotenuse of the side. So we got to figure out what that is. Like, how do you find the area given that? Well, it's just a geometry problem. We have this, so it makes a triangle, right? Well, area of a triangle does not change. It's still 1/2 base times height. If this is my base, how do I find the height? Well, it's from geometry. Most likely you have to trust me on this. It has to do with the type of triangles. So it's an isosceles. You can find the bases. These are always going to be, if that's base, this is always going to be base divided by 2. It has to do with similar triangles, but the height's always going to be base divided by 2. So if I plug that into my formula here, my height's just the base divided by 2, so I get 1/2 the base times 1/2 the base divided by 2. You get 1/4 the base squared. So that's like a brand new formula almost, right? So if you want to find the area of a isosceles triangle where the hypotenuse is the base of the solid, hypotenuse is this guy, the formula is actually 1/4 base squared instead of 1/2 base squared. It makes it more annoying, I know. It's almost as bad as semicircles, but that's where it comes from. It's just some geometry. What's my b? Well, the same thing it was before. It's just your s here. That's your b. So that doesn't change. That's still this. So it's going to be 0 to a of 1/4 1 minus e to negative x minus x cubed squared, like before, dx. So plug that all into our calculator. So bring my calculator back up. I'm just going to go up here and hit enter to copy it. You notice the only difference is instead of 1/2, it's 1/4. So it really should be my other answer divided by 2. So let's double check to make sure. Change that to 1/4 and I get 0.008. Like I said, other answer divided by 2. There you go. So that's that problem. Yeah, it's a little annoying. That's probably the most annoying one yet. Next one, until we get to these. Let R be the region quadrant 1 bounded by the graph of y equals e to the x, the y-axis, and horizontal line y equals 4. Find the area of R. So you gotta draw this one out. E to the x looks like this. The line y equals 4, so that's 1, 2, 3, 4 looks like this. And x quadrant, so right here. So it's like this is kind of our shaded area. Right there. Right, quadrant 1, so quadrant 1, so like that. So we're going to do what we always do. What do they want? Oh, it's this area. I was overthinking it. I was like, how do I do this? I was like, not how do I do this, but like, what's the conic section? What's the known cross section is what I mean to say. And they just want the area. So we know how to do area. Area is just integrate your limits from top minus bottom. So I gotta find my limits here. I have y equals 4, and I have e to the x. So I just got e to the x equal to 4. Set them equal to each other. Solve. If you want to get rid of the e, take the natural log of both sides. So I'm gonna get x equal to natural log of 4. So that's this point right there. And then I'm starting at 0. So 0 is a natural log of 4. And just like before, how do you find the area? You gotta kind of find the s. It's top minus bottom. You gotta find this guy. So that's gonna be top minus bottom. And the top here is actually 4. That's the line right there. And the bottom is this guy, natural log of 4. Sorry, e to the x. Natural log of 4 is the point right there. So just kind of going to do, just like we do cross section. You gotta find like the sliver right there. What is that? So it's top minus bottom. So 4 minus e dx. And that should be our answer. I'm going to double check by putting in our calculator. So math 9, 0, natural log of 4. There's natural log 4. Close parentheses. And then here's just going to be 4 minus e to the x. You got to put an x up here. There we go. And then over here to x. And we should get 2.545. And there we go. Next one. The region R is the base of a solid. For this solid, each cross section is perpendicular to the y-axis. That's going to be kind of a problem. Find the volume of the solid. Okay. So, first big curveball. So it's the exact same picture. Like that, where this is y equals 4. This is y equals e to the x. We know this is 0, and this is natural log of 4 is my x, and 4 is the y. Right? How do I know 4 is the y? That's literally the line right there. And we figured out natural log of 4 from earlier. Right? And then we want to find this value right here, all this. But what it says is a curveball, they want it perpendicular to the y-axis. They want us to go left and right, not up and down. So my slither here is going to be this way. So in that case, when it goes sideways, just like when we do area, we're going to do right minus left. So we're going to do right minus left. What are we doing? We're doing a square. So it's still the same problem, right? All these are always the same. If you're doing a cross section and you're doing volume, we're always going to integrate the area formula. That's all we're going to do. Area of a square, we should all know. Base times height, which is, they're the same, so it's just base times base. Right, it's a square. So I get base squared, or height, or s squared. So that's my formula. Right, the square, it's the side squared. That's the formula. I need my limits. Now again, before I put 0 to 4 or anything like that, we're going perpendicular to the y-axis. So we're starting from here and going to here. Those are my limits. This point right there, if you know your e to the x, that's 0. That's 1. I almost said 0. Right? Where does that graph cross the line? It's at 1. Ax crosses the y-axis at 1. And it goes all the way up to 4. How do I know that's 4? Literally, the line is 4. So those are my limits. And to do s, most common mistake, people leave it the way it is. They'll give me like e to the x minus 0 or something like that. Remember, it has to be in terms of y. If you're going this way, it has to be in terms of y. So I got to solve this. So let's get this equation, get in terms of y, which means get x by itself. That's all that means. So I can get rid of the e, so I'm going to take the natural log of both sides. These will cancel out, and I'm going to get natural log of y equals x. So that's what this line is. It's natural log of y now. So that's the right side. What's the left side? This line. The y-axis, 0. So if I'm doing right minus left, right, to get this little s slither, it's going to be the right side, natural log of y, minus the left side, 0. So I just get natural log of y. So that's my equation. I'll go to 1 to 4 of natural log of y dy. Right? Remember that this should always match. So natural log of y dy. Oh, and I forgot to square it. Right, because I'm plugging it in for the s formula. So it's natural log of y squared dy. And that's it. I'm going to put in my calculator to solve it. So over here. So I'm going to go math 9. I'm doing a lot more of the calculator ones than I thought I was going to do. But it's like whatever, it's nice. So 1 to 4. Put parentheses, natural log of y. Now remember, we don't have y, we're just going to put x. It's all the same, it's just a variable. Close it before you put x squared, keep in mind. Right, the square is on the natural log, not the y. Very, very important. Right, if it was y squared, I'll plug it inside. But since the whole thing's squared, close the parentheses first. And actually, I probably should close it. I mean, it's not going to matter, but to be true to what I was doing, close this and then squared. And then over here, again, we don't have a y, let's put all x's. And we get our answer, 2.596, which should match exactly. 596. And I said 2.596 because I truncated it. I didn't round it. You get full credit either way. If you round it, it'll be 2.597. Or if you want, just put a lot, and they'll truncate for you. What you cannot do is make it too little. So don't ever go like 2 decimal places. It always have to be at least 3 or more. But that's the answer. Next one. Let R be the region bounded by the graph y equals natural log of x squared plus 1. The horizontal line y equals 3, and the vertical line x equals 1. Now again, we're doing area, so I could go vertically, top minus bottom, or I could actually go right minus left if you want to go horizontally either. In this case, both ways are going to be totally fine, give me the right answer. I think most people prefer, as I do, to go vertically, so I'm going to go top minus bottom. So the left limit's 1, that's easy. So left limit's going to be 1. The right limit looks like 4, but we got to make sure. So to make sure where it actually crosses, let's solve it. We can set natural log of x squared plus 1 equal to 3. So we actually got to solve it. So then we square both, take the e of both sides. So I get x squared plus 1 equals e cubed. Subtract 1. X squared equals e cubed minus 1. It looks like it's going to be a decimal. So it might have been, I might just solve this in my calculator to get the actual decimal, but we get this. That's what we get. Again, so it's not 4. It's uglier than 4. I just want to put that in my calculator to get the value. And actually, since we're putting on our calculator, I'm just gonna do it this way. I'm gonna do it a new way. Not new, but let's do it this way. So natural log x squared plus 1. And then y equals 3. I can hit graph. Probably should make it a little bit wider. We're going 0 to 5 on both of these. So let me fix my window a little bit. See it like that. You can see the graph coming in. Again, I want to find the intersection. So second, calculate intersection. Hit enter a couple of times. And I get 4.3, something like that, right? So let's store it. So I'm going to quit. Go to enter. Hit store. And press A. So now it's stored. So A is 0.36896 or whatever. You want to write down your paper somewhere so we know A equals 4.368699. So this is A. So if you store it, you always want to write on the paper so everybody knows what you're talking about. Right? So we have that. Again, we're just finding areas. So we're going to go from 1 to A. And then all we're going to do is do top minus bottom. Now top here is 3. And the bottom here is natural log of x squared plus 1. So my area is going to be 3 minus natural log of x squared plus 1 dx. Now when we put in our calculator, this is kind of why I wanted to do it. So if I was doing this with my calculator, I'll put math 9. We're going to go 1 to A, so alpha A. And then we're going to go top minus bottom. So instead of actually rewriting it, we plug into our calculator. So I'm going to press alpha F4, Y2, which is 3, which I probably could just run by hand, and then minus alpha Y1, because that was my natural log of x squared plus 1. Press enter, and I got that, right? Which is the correct answer. Also notice how it's positive. If I would have accidentally mixed it up, it would have been negative. That's the only difference. If you switch with top and bottom, you get a negative answer, so it's easy to fix. So we get our answer. Done. Part B. The region R is base of a solid. For a solid, each cross section is perpendicular to the x-axis, so we can go up and down. X-axis means like here's the x, you're perpendicular to it, so you're going up and down. Is a triangle with the height equal to twice the length of the base. So remember, area of a triangle, area equals 1/2 base times height. And in this case, they tell us what one of the variables are. The height is equal to twice the length of the base. So the height is 2 times the base. So my area of a triangle now turns into this. Base times 2 base, which gets me base squared, right? The 2 and the 1/2 cancel out. Find the volume of the solid. Like I always say, right? Volume of a cross section is just you integrate the area formula. In this case, my area formula is b squared. So we're just going to integrate b squared. My limits, same limits as before, we're going to go from 1 to a. I'm just going to type that into our calculator. What is b? B is the exact same as the area. It's this s thing here. So I guess if I was to rewrite it, it'd be 1a of the same slice we have here, same thing for area. It's the exact same idea. So it's going to be 3 minus natural log of x squared plus 1. That whole thing squared. And that'll be dx. So my calculator, if I was going to do that, it would actually be, I wish I could probably just copy and paste it, but math 9. I'm going to go from 1 to a. And then in here, I'm going to put parentheses. 3 minus, I'll put y1. Close parentheses, and now I'm going to square it because that's the whole thing squared. And dx. And I should get 4.72. And there we go, 4.722. Okay, C. Another solid with the base is also the region of R. For this solid, each cross-section perpendicular to the x-axis is a semicircle with diameter across the base. Find the volume of its solid. So it's a semicircle. My least favorite one. So remember, area of a semicircle is 1/2 pi r squared. But the tricky thing is, let's go up there and let's actually draw it. A semicircle looks like this. So the radius is only half of s. So in this case, that's going to be 1/2 of top minus bottom. Right, so that's gonna be the r we use. It's gonna be half of the whole slice, so 1/2 of s, 1/2 of 3 minus natural log of x squared plus 1. So for here, right, all we're doing is integrating the area, which is integral of 1/2 pi r squared, which is gonna be integral from 1 to a of 1/2 pi. Now r is gonna be the same thing from before, divided by 2, because we took the radius instead of the whole thing. And then that is squared dx. We plug that in, we should get 1.854. So let's plug that in real quick. Math 9. We're going from 1 to a. And then here I'm going to do 1/2 times pi. And then I'm going to go parentheses. I might do the alpha y equals. And then I'm going to do 3 minus alpha f1, all over 2. Then come over here, get out of this. Close the parentheses first, sorry. And then we square it. Right, you got to practice your calculator a bit, but that's that. It's all in there. And then press X, hit enter, you should get 1.85. There we go. So there's that one. Let's move on to the next one. Question 8. Let R and S be regions bounded by the graphs of f of x is 1 minus cosine x, g of x is square root of x, and quadrant 1. Find the total area of the regions bounded by f and g. So we got to find the total area. So r plus s together. First, just like before, we got to find our limits. So let's figure out what they intersect. Got to use your calculator for this one. So let's go y equals. I get f to the top one, 1 minus cosine x. Make sure you're in radians. You should always be in radians for calculus. Then square root of x. Like that. Always fix the window also. Now we're going from what? 0 to 2 and then from 1 to 4. This helps you see it. So my x is going from 0 to 4. My y is going from 0 to 2. Hit graph. And there we go. Now again, we gotta find the intersection. So there's 2 of them we gotta find. So second calculator, we're gonna do it. We're gonna have a A and a B. Let's find the intersection. Let's first find this one. It's almost there. Enter, enter, enter. 1.9962. Oh, almost 2. So let's get out. Quit. Let's put answer. I'm gonna store that for A. Whoops. Store A. That's because I hit something else besides. Oh, that's annoying. So let's do it all over again. Second calculator. Yeah, I'm not cutting this out. You get the full unabridged video. Do all that. Get this. So that quit. Answer. Store. Alpha A. Right? That's real. It's a mistake. How to store it. So again, you got to write down somewhere. So let us know that A is 1.9965248. Now we got to go find B. So get back to my graph. Second calculator. Intersects all the way over there. Close enough. Hit enter a couple of times. And we get 3.599. So same idea. Let's quit. Got to store this guy. So second answer. Store. I'm going to put this as B. Oh, man. I don't think it's going to work anymore. I think I have to go back. Let's see though. Yes, it worked. 3.599. So again, let us know that what B is. So this is B. This is A. And B equals 3.599138. So they're both stored. We both have them all. If I want to find the area, it's actually not that bad, right? Area is going to be top minus bottom. My top here, this one right here is square root of x. I could tell because the way it's curving. The bottom right here is the cosine of x1. So this would be g of x. And this one would be f of x. Now remember, we're doing as long as we all know what that is, you just write it this way. So we're going to go from 0 to A. In quadrant R, it's f of x minus g of x. dx. Plus quadrant B, we're going from A to B. Quadrant S, we're going from A to B. And in this case, we flip it. Now g of x is on top, minus f of x. And then that we just put into our calculator. So math 9, we can go from 0 to A, alpha A, whoops, my mistake. And then here, f minus g of x. Remember, f of x for us was y1. Now on your paper, you don't put y1, you put f of x. But for us up here, we know, okay, it's y1. So alpha y1 minus y2. X. We're going to add in the other integral. So math 9. And we're going to go from A to B. And this one will be y2 minus y1. Get out and then put x there. Hit enter. And we get our answer, hopefully 1.078. Let it think. It's alright. Negative 1.678. I messed something up. Is my y1 f of x? I did mess something up. You could see it. F of x is cosine. I had these labeled incorrectly. Right? Remember, it should be negative. So this is actually f of x. F of x was a cosine one. And this is g of x. So I had these labeled incorrectly. It's the other way around. This is g of x minus f of x. And this is f of x minus g of x. Sorry about that. I had them labeled wrong. But notice how I could tell. It's negative. I was like, I must have flipped them. And I did flip them. So that's the idea. And actually, if something had to happen, I just changed it. And then I go, okay, that row answer is this. Done. B. The region R is the base of a solid. So we're only talking about R right now. For this solid, each cross-section perpendicular to the x-axis is an equilateral triangle. Find the bottom of the solid. So again, anytime I see this, for me, it's my favorite type of question. Cross-section, volume, I'm just integrating the area formula. As long as I know the area formula, it's all good. Area formula in this case is an equilateral triangle. So you just do enough of them, you start memorizing it, which is square root of 3 over 4 s squared. That's the formula. So now, we need our limits. Well, we're just doing R here, so we're going to go from 0 to A. And then it's going to be top minus bottom. So as long as I don't mess it up this time, it should be G minus F. Sorry about that. That's not right. Right? G minus F is our S here, right? That's what that is. Right? We got to find our S, which is this guy. The little slither of our equilateral triangle is what we're looking for. So my S here is G minus F, top minus bottom. That's what it is. So I'm going to plug square root of 3 over 4 times my S, which is G of x minus F of x, squared dx. Now we just plug into our calculator. So I'm going to go math 9, go 0 to A, alpha A, and then we're going to go square root of 3, second square root 3 divided by 4, and parentheses, g of x minus, so remember g of x was y2, so second y2. And actually before I do this, I got to square it all. So did I put parentheses? Yeah, I did. Just making sure. So we're going to do y2 minus y1 and then we're going to square it. I guess since we're squaring, it doesn't actually matter which one's which. And then dx, and we should get our answer, 0.165. And there we go. Next one, the region S is the base of another solid. For this solid, each cross-section perpendicular to the x-axis is a semicircle. Find a solid. So again, semicircle, my arch nemesis. Area of a semicircle, easy, 1/2 pi r squared. But the picture is less easy. If I erase this, actually I didn't need to erase, so we're doing S this time. Right? Semicircle looks like this. So remember, for a semicircle, your radius is half the R, half the S. So for a semicircle, R equals 1/2 S. We know S in this case is F minus G. So we just plug it all in. We're just integrating the area formula because it's a cross-sectional volume. In this case, that's 1/2 pi r squared. We're going from, now since we're doing S, we're going from A to B. And then all we gotta do is plug in R. So it's gonna be integral A to B, 1/2 pi r squared. Now instead of R, I'm gonna put F minus G divided by 2. Right, because again, radius is 1/2 of that. So this divided by 2. That's all squared dx. And let's put in our calculator, and we'll get 0.024. Now you could try yourself, see if it works. Number 9. Region in quadrant 1, bottom of the graph, so y equals 10 inverse of x, and y equals 1/2 of x is the base of a solid. For a solid, each cross-section perpendicular to the y-axis, so we're going to go left and right, is a rectangle with height 4 times the length of the width. Find the volume of the solid. So again, I know it looks scary, but all we're doing is finding a cross-section volume. So all we have to do is find the integral of the area formula. And our area this time is a rectangle with the height 4 times the base. Area rectangle is base times height. In this case, we know the height equals 4 times the base. So if I rewrite that, I get base times 4 base, or 4 base squared. So that's what we're working with here. Right, all we gotta do is find the limits of this guy and figure out what b is, so like what that slice is. And then we can just plug into our calculator and we are done. So let's try to draw a picture of this. So tan inverse. I'm not sure if you guys remember what tan inverse is. Don't worry, it's only AP calculus. Tan inverse graph looks kind of like this. It's like an x cubed, it's like a cube root graph. And then we have 1/2 x. So it's gonna be kind of like this. Now we only want the first quadrant, so we only care about this part right here. It's the only part of it we're really going to care about. If you want to sure, we can also, let's use our calculator graphic, because I'm not going to solve this. So we're going to go y equals, probably didn't need to graph it by hand, but wanted to show off. So tan inverse, so inverse tan of x. And then we're going 1/2 x, so 1/2 times x. Graph, I'm going to leave the same window from we had before. It should work out, but if not, we can always adjust it later. So there's that part, and then there's our 1/2 x. So there's the intersection we need. Now keep in mind, full disclosure, I did this problem and I had to go back all the way back because I forgot we're perpendicular to the y-axis. It was like 10 minutes, and I was like, I'm not going to put you guys through that. So remember, we got to go to y-axis. So what does that mean? I still got to find the intersection here. I'm still going to do it this way. But when I find it, I actually only care about the y value, not the x value. So for 0, 0, I'm actually right here at the origin. So it is 0, 0. I want to find this intersection over there. Remember, we're going to go perpendicular to the y-axis. We're going this way, perpendicular to the y-axis. So enter a couple times. There's my intersection. And again, I actually want the y value. So I'm going to save it up here. Let's say this point is, I don't know, b. B is 1.1655612. You might ask me, why didn't I store it? You can only store the x values. You can't really store the y values. So I just copied them all down because that should be good enough. That's good enough. It's good enough. If you want to store that value, you actually got to find the inverse and switch it and graph it again. So in this case, I'm just going to save it because you can only store the x values, but I actually need the y value here. Remember, we're going perpendicular to the y-axis. So a lot of this is still the same. My limits now, we're going from 0 to the y value here, which was this guy. So that's what my y value is. So I'm going to integrate from 0 to b for b squared dx. Now remember, I got to find what b is. That's this guy here. We're going horizontally. So b is going to be, not b, sorry. Well, I guess little b would be right minus left. Really should have made the intersection point an A. It's embarrassing. So remember, right minus left, but I can't have it in terms of x's. Right now they're both in terms of x's. I need them to have it in terms of y. So you got to solve for x. So let's do each one separately. So let's first start with this. Y equals tan inverse of x. How do I get y by itself? How do I get x by itself? Well, you get rid of the tan. You do that by taking the tan of both sides. You take the tan of both sides, you get tan of y equals, these cancel out, equals x. So that's what the purple line is. That is tan. That actually looks like the left side. And then for the right side, we got to do this one, much simpler. If you're trying to get x by itself, you just multiply everything by 2. So x equals 2y. So that's this line here. So that's the right side. Right side's 2y. The left side is going to be tan of y. So my equation now becomes from 0 to b. And that probably shouldn't put b. I should just put the letters because b's not in my calculator anywhere. So you'll see when I put in my calculator, I'm just going to literally put the numbers, the letters. What am I doing? 4b squared dx dy. But I know what b is now. It's 2y minus tan of y squared dy, we're in terms of y. Put that in my calculator. Move this over here. Second quit, math 9. We're going to go from 0. Now again, I don't actually have this stored because there's a y value. You can't store y values as easily. So 1.1655612. That still works. It's you don't have to store it anytime. You just write them all down, but it's much easier to store when you can store. Then we're going to plug in the formula. So it's 4 parentheses, right minus left. So 2y, we'll just use an x, minus tan of x. Make sure we're in radians. And that whole thing is squared. You notice double parentheses because tan itself has a parenthesis. But I wanted a parenthesis for this whole part. And then we press an x over here. We hit enter. And you get 0.77, which is the right answer. One last problem. The base of a solid is a region in the first quadrant bounded by the y-axis. The graph of y equals tan inverse again. The horizontal line y equals 3 and the vertical line x equals 1. Bottom of solid of each cross-section perpendicular to the x-axis is a square. What is the bottom of the solid? So lots of things going on here. So there's like 3 graphs. Here's the most important thing, right? So we're doing cross-section perpendicular to the x-axis. Oh, that's the pretty one. That's up and down, right? X-axis is like this. Perpendicular is going up and down. So we'll go up and down for this one. And right, so cross-section, it's a square, and we're finding the volume. So we're just going to integrate the area formula. And since it's a square, we're just going to integrate area of a square, which is just s squared. My integration formula looked ugly, like that. A little nicer. Okay, now let's draw this thing. As I mentioned before, tan inverse. Let's not be scared about it. It's kind of like a cube root graph, I should say. That's like tan inverse. Y equals 3. So let's say 1, 2, 3. That might be a little off. We'll put it in our calculator to make sure. And the line y equals 1. X equals 1. So like this. So base of the solid region of the first quadrant bounded by the y-axis. So bounded by the y-axis. The graph of that horizontal line and vertical line. So I actually want this part right here. Right, notice how it says bounded by the y-axis. So it's not this region, it's this region. Let's graph it and make sure. So let's go y equals, I'm going to have tan inverse again, have that done. I'm going to have y equals 3. Oops, that's embarrassing. Tan inverse of x. And then y equals 3. I can't do x equals 1, so you just have to do that visually in your head. I can't even see 3. Look at that. Remember, I'm going 0 to 2, so my one doesn't even go up to 3, so I gotta fix that. My y should go all the way up to like 4. So it's into this, like, to this effect. Y equals 3, and then 1. So you can see it's kind of the same thing. It's right there. Now the good thing about this is I have my limits already, right? We're going vertical. We're going up and down. So we're starting at 0. We're going to 1. How nice. All we need now is the slice here. We want to do a square. So my slice is kind of like this. So remember, all the slice is top minus bottom. To find my s, my top here is the line y equals 3. So 3. And the bottom is the tan inverse. So there we go. Plug it all in. 0 to 1 of 3 minus tan inverse of x squared dx. Plug that into our calculator and we are done. So I'm going to quit. Math 9, 0 to 1. Now again, notice I'm going to put parentheses so I can type this all in and square it. So 3 minus tan inverse of x. Close it, and close it again. So now I have my little portion right there. Then I can square it. And go over here, press X, and we should get 6.612. And there we go. 6.612. And that's the homework.